The last topic for this week is we go further, right? So we had three lines, triangles, and then what happens if there's more than three lines? We won't be studying each of those shapes in great detail, but we categorize them generally as polygons. So it's something that has many sides. Again, there are some terminologies here which, as a part of your homework, I would want you to complete them. I'm going to discuss them anyways. Convex polygon means a line connecting any 2 points lies inside the polygon. For example, if you take a good old square or rectangle, any 2 points you draw, no matter what way you draw, it's going to be inside. Or if you take a pentagon, any two, it doesn't have to be the vertex. Yeah? Any line you draw between 2 points on the polygon lies inside, then it's convex. Concave is if lines connecting any 2 points are not entirely inside the polygon. So this can happen in what are called irregular shapes, something like this. By definition, this is a pentagon because there are 5 sides. But if I take these points, right, this is outside the polygon. So these are irregular. They're not very nice because they don't satisfy this very nice property. Equilateral polygon means all sides are equal. Equiangular polygon means all angles are equal. And then lastly, you have a regular polygon. It's a polygon that is equilateral and equiangular. Yeah. Example, square. What you have in a square is that all sides are equal and all angles are 90 degrees. Or we looked at something called an equilateral triangle, remember? Examples of polygons are quadrilateral, 4 sides, pentagon, 5 sides, hexagon, 6 sides, octagon, 8 sides, that's a stop sign, and so on. So let's focus on quadrilaterals. Again, types of quadrilaterals, I want you to fill this in. Parallelogram, the only requirement is that the opposite sides are parallel. Okay, so that is a parallelogram. And we can use these arrows to denote which sides are parallel. Now, rectangle is a parallelogram with angle equal 90 degrees. So what you do is you take the parallelogram and then you straighten it up so that all angles are 90, which means that these are parallel still. Square is a rectangle with all sides equal. Okay, so you take a square, these are all equal, and this is 90 degrees. And then so on. So over here, I would ask you to fill this in. Make sure you read it from the book before you go ahead in the video because we will be talking about trapezoids. A result that we will be talking about or using is that the sum of the interior angles of a polygon of n sides is equal to n minus 2 times 180. Example, if you take a quadrilateral, that means 4 sides. So something like that. So this is angle 1, this is angle 2, angle 3, and angle 4, then angle 1 plus angle 2 plus angle 3 plus angle 4 is n, which is 4 minus 2 times 180 degrees. 2 times 180, which is 360 degrees. We'll look at an example here. Find the value of A. So first of all, there are 5 sides, which means n equals 5. So angle A plus 98 plus 93 plus 105 plus 118 should equal 5 minus 2 times 180. That's angle A plus, let's combine these, it's 191, combine these, that's 223, it's 3 times 180. Or angle A plus, combine these, it's going to be 300, 410, 414. 3 times 180, that's 30 and 24, so it's 540 degrees, which means angle A is 540 degrees minus 414, which is 126 degrees. So you can find the missing angles. Another result is that the sum of the exterior angle of any polygon is 360. Now what is this exterior angle? Is you extend every side and then you look at all the angles from outside. For example, if it were a square, it would be something like that. So 90, 90, 90, 90. And these also add up to 360. So that's true for any polygon. In the next video, we will look at some properties of the trapezoid.